This conference will now be recorded.
Yeah, in today's session, we're going to discuss about the Pandas data frame, how to view the data, okay, how to filter the data, how to delete the data. We're going to see one by one. The first thing we're going to see how to view the data. If you are creating a data frame, it will be a two-dimensional array. It can going to contain three major elements. One is data, another one is x-axis is nothing but rows, y-axis nothing but columns. These three functional axes is very important. The Pandas data frame. Using the Pandas data frame, we're going to view the data. Now you want to import this library. Import Pandas as PD. Yeah, I'm going to view the data. It is going to view the data. Yeah, it is going to be view the data. Now I'm going to read from a CSV file. The CSV file kept in this folder, ML folder, machine learning folder. We have one data set called NBA dataset. Just copy this path and provide us data frame equal to pd dot read CSV. If you are using some flat files, you can use read CSV. If you use text file also, you can use read CSV. If you are trying to read some text file or dat files, you can use read CSV. Okay. Now, what I'm going to do here, I'm going to provide the escape sequence. In that, I'm going to provide a path. After that, I'm going to provide nba.csv file. Okay. If you are not, I want to skip the header, you want to skip your header, you can if you want to skip your header, you can mention header equal to none. Header equal to none. Okay, header equal to none. If you want to skip some rows, okay, if you want to skip some rows from the top, you can use skip rows equal to 2. If you want to skip footer, from footer you want to skip 5 rows, you can use skip footer. And then if you want to skip the blank lines, okay, you want to skip the blank lines, you can provide like to should mention T should be caps. Okay, these are the various attributes you can pass to the read CSV API. Okay, as of now I require header. As of now I require header. Now I'm going to make remove the attribute header equal none. Okay, as well as I want to remove this property as well. Yeah, I want to add this attribute skip blank lines equal to 2. Now I'm creating the Pandas data frame. Okay, now I'm creating this Pandas data frame. It's actually a warning. Can leave as it is. Okay, now I'm going to view the data. If you want to view the data from the top, you can use head. Head means header. Okay, now what I'm going to do, I want to return around 12 rows. Okay, you can mention number of rows equal to 12. Number of rows equal to 12. And then, yeah, before that, I want to see all the columns. Okay, if you want to see all the columns, you can use double tap, and then you can search for this API. Okay, one minute, yeah, df dot columns. It's going to give all the column names. It's going to give all the column names. Yeah, it's going to give all the column names. As of now, in this file, we don't have any header. We don't have any header. Yeah, we have header. Why it's header not showing here? Name, team, number, position, age is there, right? Okay, let me. We'll take head, yeah. df dot columns, why it's showing j crowder? 1 minute. df dot head, df dot head. Okay. Yeah, what it's happening here is we have skipped the skip rows equal to. Okay, now I'm going to remove this property attribute. Sorry, attribute. If you provide df dot head, now the header is going to be name, team, number, position, age, height, weight, college, and salary. Okay, because in the read CSV API, I use skip rows equal to. That's why the first two rows are skipped, and third row as treated as header. Third row is treated as header. That's what I mentioned here is skip rows equal to. I mentioned previously. Now, if you use skip rows equal to, first two rows will be skipped. Now, third row will be treated as header. Okay. Now you can use a skip rows equal to as of now. If you provide df.head, you can get the first row as header. Now, if you want to see the column names, I want to see only the column names. What method I can use? df dot columns. You can able to see all the column names. In pandas, we will say it's index. We won't say it's column names. We'll say index. Okay. If you see the, we can say various index, name index, team index, number, position, age, height, weight, and then all the type it belongs to a object type. Object type means it's similar to string only. Okay. Name, team, and then number, position, age, height, weight, college, salary. The object type means it's a combination of all types, like not only string, int, float, double, because every type is belongs to your object. Okay, that's what I mentioned in data type is going to be object, not only string, int, float, double. Okay, everything is belongs to your object. Now, I want to view the first 12 rows. I want to view first 12 rows. Okay. Now what I going to do? I want to select only the name column. I want to select only name column. What I going to do? Data frame 1 equal to data frame. Okay. In that you have to provide the index. I am going to select only the which column? Name column. Okay. Name column. And if you provide df1, you can be able to see all the names present in the index of name column. You can see Aver Bradley, Joe Crowder, and then Joe Highland, RJ Hunter. Okay. If you want to select the team, you can select DF. You can pass. Sorry, you can pass. You can select the 1 minute. I'm going to copy and then paste it as team. Now you can able to select the team members. Okay. Okay. If you are selecting a single column, we will say it's a Pandas series. I'm going to mention here. If you are selecting a single column, we can say it's Pandas series. You know what is Pandas series? Pandas series means it's a single dimensional array. Single dimensional array. Okay. If you're selecting more than 2 columns, it's not going to be a single dimensional array. If you're selecting a single column, it's going to be the Pandas series. It's going to create a single dimensional array. Okay. Or we can say it's a one dimensional array. Not only say it's a one dimensional array, it's a one dimensional labeled array. Do you know why they're saying labeled array? See, I select only team members. For every team member, I have a label. What's a label? 0. And then for Boston Celtics, I have label is 1. And then Boston Celtics label is 2. Boston Celtics label is 3. Okay, up to I have like around 452 labels are there. If you are selecting a single column, you can say the Pandas series. It's going to be a one-dimensional label array capable of holding any data type. It can be a int data type, it can be a string data type, it can be a float data type. Okay, it can hold any data type. Definitely, if it's a Pandas series, definitely there should be a access label should be there. For this Boston Celtics, what's the label? 0. In SQL, will say index. Okay, but they're saying in Pandas series they're saying it's labeled array. For every value we have a label. Okay. Okay, labels may not be unique. You may think labels may not be unique. It can be any hashable type. It can be any hash value. Okay, don't think like that. I should have only integer. I should have anything. Not like that. It should not to be unique. It should not be unique. It should not contain any hashable type. Any hash values it can contain. As well as any Pandas series free data frame, it can contains like integer. Okay, this it contains an integer, string, float, double. Any this Pandas series can contain any data type, can be integer or a float or double or can be string. Okay, now what I did here, I created a Pandas series. It's a one-dimensional array. Okay, it's capable of holding any kind of data type, can string data type, and float or integer, string. Okay, now I created a Pandas series and assigned to a variable called df1. Now I want to select first 12 rows. Here I mentioned number of rows equal to 12, right? Now I want to select 12 rows from my team. How you can do? Just do one thing. I want to select 12 rows. Okay, top 12 rows. Top 12 rows with a variable name equal to df1 dot head, and then you have some variable called n equal to, you want to pass number of rows equal to 12, right? Just pass this variable here. That's it. Now I can able to select 12 rows. If you include 0, I can able to select 12 rows. These are called labels. Okay. Okay, fine. This is how you can able to select the first 12 rows. Now I have one column called salary column. 1 minute. I check this column names. I have some salary column. From salary column, I want to select from bottom. I want to select 12 rows. How you can do? From salary column, I want to select 12 rows from the bottom. Give the data from salary column. Okay. From bottom, I need 12 rows. What you have to do? Number of rows you can mention again 12, and then you can mention bottom df dot. Sorry, df. You have to pass salary. You can just copy and paste just salary, right? From here you can pass. It should be caps. First you have to create a Pandas series. Now create the Pandas series. Pandas, it's a one-dimensional frame. Pandas is it's a one-dimensional data frame. It's a one-dimensional data frame because salary column, how many dimensions will be there? Only one column will be there, right? It's only one dimension. Only one-dimensional data frame. Okay. Now I want to select the bottom of 12 rows. What do you have to use? Bottom of 12 rows.
You
Here
have
I
to use
make
tail.
tail. Yeah, that's it. You have to use the tail. You can give bottom, sorry, bottom equal to df2 dot tail. Okay, df2 dot tail, and then you can pass n. N means number of see now wait tail 1 minute. But pass a n value n equal to and then number of rows. Okay, and then display the bottom value. Now you can able to see. Now you can able to see the only one dimension data frame. It's a only one dimension data frame. What data type belongs to? It's a float values. You can able to see dot zero is there, right? That's the float. It is 64-bit value. Fine. This is how you can able to view the data using head as well as tail API. Now I want to view some basic statistical information about my data set. Okay, I want to see my mean, median. Okay, these kind of information I want to look for. If you want to look for any kind of statistical informations, view statistical information about your data set. Whatever you use, I have to use describe. Okay. Before that, I want to say a few things. In my data set, okay, 1 minute, I will search for if is null. Okay, is null, and then I will find the count whether I have any null values or not. Okay, what I am trying to do here is in my data frame, I checking for any null values are there, and then I find the count. In name column, how many null values are there? 1 minute, it's not giving the right one. Okay, 1 minute. df dot size. It is around 4,700 rows. Okay, it is having 4,700 rows. It has okay. It having 4,700 rows. Out of 4,700 rows, I have some null value. Name column I have 450 null values. I have team column I have 4 null values. And size is 4077. 1 minute, I'll check my data set. I will check my data set. How many? Showing only 458. Showing like around 458. 1 minute.
This conference will now be recorded.
Now, I want to find whether NA value, not a value, is available in data frame or not. Okay, I want to use df dot is NA and then I find the count. In name column, is there any not a value is there? No, 0. Team column, nothing is there. Number column, 0. And then in college, I having 82 rows. I having a not a value NA. Salary column having 11 rows. I having not a value. Okay. If I want to drop all this not a value rows, I can use one API called DataFrame drop NA. Whichever the values you are having not a value, you can able to drop. Okay, what you have to do, drop NA in bracket. You can use a double tab, you can use in place in place equal to, just pass very true. If you provide in place equal to, what happens? It will remove the not a values from this data frame DF. It will remove the values. It will remove all the rows. Whichever n value is present in the row, it is going to remove all the rows from the data frame DF. Now I'm going to remove, and then I'm going to run the same thing whether any null value present or not. Now look at the result. College is showing 0. Salary 0. What happened? I removed all the rows. Whichever n is present, not ever is present, I'm going to remove all the rows. After that, now if I check is n at sum, in name column I have not a rows not there, and the team column 0, number column 0, and then up to salary column no not a value is there. This is how you have to remove the not a values in your data frame, Pandas data frame. It's very important actually. If you want to remove any not a values, you can use drop NA. You have to use in place equal true. In place equal true means it's going to remove from your data frame. It's going to remove all the rows plus whichever row present NA, that rows will be removed from the data frame. Okay, now I'm going to check the count. Previously my record was 457. Now how many rows are there? Initially 457 rows are there. After removing all the not a values, how many rows are there?
362.
360 rows are there. Okay, if you want to use count, it will give the count for each columns. Name have 60 rows. Team column has 60 rows because I removed all the not a values. It's showing 362. Okay, this AP is very important. Which AP is very important? Drop NA. Drop NA, and then you have to place in place equal true. If you put in place equal true, once you remove all the rows, you can't recover it back. You can't recover the data frame again back. Okay, again you have to create the framework.
Okay.
From scratch, from initially only. You have to create the framework, data frame. Sorry, you have to create the frame from initially only. You can't recover the rows whatever you have dropped. Fine. Now I want to see some statistical information. After removing all my not a values, I want to see some statistical information like mean, median. Okay, like I want to see all the informations. The only one thing you can see is you can use describe. It's an API. You can use df dot describe. It's going to give you the very statistical information about your data set. Okay, it applies only to your int column as float column. String columns you can't apply any static information. String column, can you be able to apply static information? No. For a string column you can't apply any static informations. Can you apply mean for string column? No. Only numbers column only you can able to find the mean. That's what it's showing only 4 columns. Okay. You can see number, age, weight, and salary. Number, how many count is there? 362 rows are there. 362 rows are there. What next? Mean means you know, right? You want to add all the rows and divide by total number of rows. Okay, you want to add all the values in the rows and then divided by total number of rows is 362. If you divide, you will get the mean. Okay, and then for age, what's the mean? 26.6. For weight, 219.80. You're getting some average, right? For standard deviation, you know standard deviation formula. Standard deviation formula, exponent mu by sigma. You can use standard deviation formula. If you apply this thing, you will get the standard deviation for this row or for this column. You will get standard deviation value. This is how you can get the statistical information. For 20%, this is the value. For 50%, this is the value. 70% this is the value. What's the maximum value? The number. This column we have a max number. What's the max number? 99 is the max number. For age column, max number is 40. For weight column, someone is having some weight. Okay, NBA 279. And salary It's giving some exponential value. Okay, 2.3. This is a max value. This is how you can get the static information about your data set. Now, I'm going to add few more parameters. I want to find for 20 percentile, 40 percentile, 60 percentile, 80 percentile. Okay, I want to find some information about that for 20 percentile, 40, 60, 80 percentile. Okay, and then I want to find statistical information only for the data type of object floating into. The remaining things I want to exclude. Okay, now what I'm going to do, I'm going to set some percentile. Default is giving only 20 percentage, 50 percentage, 70 percentage. But what I'm going to do, I'm going to have one variable. In that variable, I'm going to have one uh, list 20 percentile, 20 by 100, 0.2, right? And then 40 by 100, 0.4, comma, and then 60 percentage. Okay, 60 to 100 will be 0.6, and then 0.80, 80 to 100 will be 0.8. Okay, now I use a variable, and then I want to include. I'm going to have one variable called include. Okay, I have a set of columns. Some columns will be object type, some columns will be a int type, some columns float type. Okay, I am going to include. These are columns I want to find. The columns is going to be float. I want to find. The column is going to int type. I want to find the percentile. Okay, let's give include. I have two variables. One is percentile include. Now I'm going to have variable called describe. Sorry, ds describe equal to my data frame dot describe. In that you can use shift tab. If you use shift tab, it will give the detailed information. Okay, you have to use shift and double tab you have to use. Then you will give what are the attributes you can pass to the API. Okay, what are the attributes you can pass? Percentiles, include, exclude,
Exclude
and
and
then
data.
date time also you can pass. Date time also you can pass. Okay, if you want to know detailed information in the Jupyter notebook, you can place a cursor over here and shift. You can double tab. You can press. Okay, now I'm going to provide use tab percentile is equal to percentile, because I have variable called percentile, and then I'm going to include. We have one attribute include equal to. Don't get confused. Okay, this is a key. This is going to be a variable. This is going to be the include is going to attribute key. It's going to the value whatever you have defined here, and then what are things I want to exclude. What are things I want to exclude is, sorry, exclude is that right? Exclude. Exclude equal to, I'm going to exclude something. Okay, like I'm going to mention, like I'm going to exclude the object. Let's see, because object contains all types, right? Object contains all the types. Okay, now I'm going to make want to exclude the double. Okay, yeah, UPSC, run the script. What happened? Okay, I am getting some error. Include, exclude, overlap on functions. Okay, okay, leave it part. I want to mention like overlap. Yeah. Now you can see default is giving 20%, 50%, 50%, 75%. But I want to find for 20 percentile, 40 percentile, 60 percentile, 80 percentile. Now you can able to see 20 percentile, and then what I mentioned 40 percentile, 40 percentile, sorry, 40 percentile, and then I have 60 percentile, and then I have 80 percentile. Okay, because the 20 percentile, and then I have mentioned like 40%, 60%, 80 percentile. Okay, this is how it's finding the value for this number column and age column, weight column, salary column, because we are considering only float and int. Okay, that's what these four columns might be. This column will be a float type. This column will be float type. Float type. This might be again float type. Okay, that's what I'm making include equal to float and int, and then for this values I calculating the percentile. It's giving the static information about data set, and then max value is going to 99, 40. Okay, okay, let it be. Now next thing is I want to convert my Pandas data frame into NumPy array. I want to convert it to some dimensional array. Convert Pandas data frame to NumPy array. Now I go into same data frame. I go into same data frame, and then in the data frame I am going to convert to a NumPy array. Okay, it's very simple actually. What I'm going to do, I'm going to use a print statement. Already have data frame. In the data frame, I remove the not a values, NA values, and then df to NumPy. To NumPy we have to use. That's it. I want to convert a data type into 32-bit. D type equal to float 32-bit. Float 32-bit. Default, this database belongs to a float 62-bit, but I am converting to a NumPy. NumPy means it's a numerical array. Numerical array. Just see here. What happened? Could not convert string to float. Okay, could not convert string to float because what I did here is instead of selecting these columns, I selected enter data frame. I selected the enter data frame. Now, what I'm going to do, I am going to select only a single column in data frame. In the data frame, I'm going to use weight. This column alone, I'm going to convert from data frame to NumPy array. Now you can able to see the array. See the brackets. Now the data frame is converted to numerical array. Numerical array. Okay. What we have to use to convert data frame to numerical array? To NumPy. To NumPy, and then whichever data type you want to convert, you can mention the data type equal to float 32-bit. Okay. See, each API will have different attributes. If you double click, there are n number of attributes are available. For your requirement, you can pass only a data type equal to float 32. Okay, fine. Because you can apply only to your multiple columns also you can apply, but if you use only data frame, in the data frame we have your object as well. String also we have, right? For string you can't convert to numeric array. String we can't able to convert numeric array. Can't convert to array. Okay, that's what. Only integer values, float values, double values can convert into integer array. That's what I am choosing the only one column. Okay, the column is going to be on. Now I'm going to choose number. Now I'm going to choose number. Okay, for number column is going to numeric array. Okay, now if I want to convert two or more columns to a numeric array, let's try comma. In that I am going to pass weight. Yeah, 1 minute. Yeah, like the above exception was there because of the following exception, number and weight. Okay, it's not accepting actually. 1 minute. And can able to correct numbers. Okay, data equals float 32. Why it's not accepting double values? Okay, numerical values. Yeah, numerical values. P of data frame. Okay, yeah, like numpy is nothing but a numeric array. Okay, it's going to be a one-dimensional array. Sorry, I forgot to say this. NumPy array is going to be a one-dimensional array. Okay, though it enabled to have a single column can convert into array. Okay, these are the values present in the data frame. I convert into a array format. It's going to be a one-dimensional array. Multiple dimensions cannot be able to convert. Okay, but you can able to convert 2D into 3, 1D, sorry, 2D into 1D can convert. But as of now, I am selecting only one column and convert the numerical array. Okay, next thing, what we can see, yeah, next we're going to see the Pandas series. Pandas series, we're going to see more examples on Pandas series. Pandas is nothing but a one-dimensional labeled array capable of holding the data of any type. I already said to you, it can be integer type, it can be string type, it can be float type, or any kind of Python objects. The axis labels are currently called as index. Whatever is seeing in the Pandas series, right? Every row will have a label. We will collectively named as called index. Labels need not be unique. Okay, not be unique, but it must be any hashable type. Any kind of hash value also can contain int value, can contain any hash values, but need not be unique. And then mostly this Panda series supports both integer as well as label based indexing. Okay, supports both. Now we're going to see Panda series. Okay, I'm going to have one array. Now I'm going to have one data set equal to np numpy. Sorry, what I have to do? I want to import one module. Import numpy as np. Through this module, I'm going to create array. Data set equal to np array. Okay, in that array, what I going to do? Hello h and then e l and then one more l and then o. Hello. It's going to be array. Array means already know. Same data type. Same data type. Okay. As well as array is somewhat mutable. Okay. Now I want to create though it's an numpy array, I want to create into Pandas series. Okay. Now I'm going to use ser equal to, I have Pandas pd dot series. I want to make caps. Yeah. Pandas dot series. In that you have to pass the data set. You have to pass the data set. Okay, yeah, I'm going to pass the data set. First, you're going to print the value. Now it's printing hello. Okay. C is nothing but your one-dimensional array. It's a one-dimensional array, as well as it have a labeled index. We can able to see for H it will be index will be 0, and E for index will be 1, and L will be 2, and L will be 3, and 0 will be 4. Okay. This is how you can able to create a Pandas series. Pandas is going to be a one-dimensional labeled array. One-dimensional labeled array. Now you can set some different index as well. Default index starts with 0. Okay, for each array it's going to assign some value, but if I want to set some different index, you can do. How you can do in the sense, str same variable pd dot series, sorry, s should be caps, series. In that I going to provide the data set, and then I'm going to provide the index. Externally I'm going to provide the index. For example, I'm going to provide the index as 100, 101, 102, 103. How many? 1, 2, 3, 4, and then 104. Now, if you print the SCR, now for H, what's the index? For H, what is the index? 100. For E, the index is going to be 101. For L, it is going to 102. For O, it is going to 104. Externally, you can set the index for Pandas series. For example, in your company, they're giving some on DataFrame. They ask you to convert into a one-dimensional array. You have two APIs. What are two APIs you have? You can use 2 NumPy. You can convert. What you can convert? You can convert the one-dimensional array, as well as you can use Pandas series to convert into one-dimensional array. These are two APIs you can convert from n-dimensional array to one-dimensional array. Okay, fine. Okay. Now we're going to look at the one more API. Okay, how to retrieve the rows. How to retrieve the rows, or you can say how to filter the rows. Oh yeah, as of now we will see only how to retrieve the rows. Okay, how to retrieve the rows. I have one data frame df, and then I have one API called LOC. LOC stands for location. Okay, LOC stands for location. You have to pass only the index. You have to pass only index in the LOC. If you want to know the index of data frame, you can use df.columns. It's going to give all the columns indexes, right? Now, if I want to select particular column, I can use LOC. In the LOC, what I'm going to do, I'm going to provide name. 1 minute, 1 minute, 1 minute. LOC name is not defined. 1 minute.
This conference will now be recorded.
Now, what you have to do, LOC stands for location. Okay, now I'm going to filter few of the rows. What you have to do first, you can pass the name column. It's going to give various values for you. Okay, in the name column we have various values. Now I want to filter my rows. Okay, I want to filter whichever rows having the row hood. I want to filter this rows. What you can do, df dot LO stands for location. In the LOC, you should not pass any integer value. You should pass only the rows. You should pass only the rows. Let's pass a Ronnie Hood. What's happening here? I'm passing Ronnie Hood. Ronnie Hood is not available. 1 minute. Ronnie Hood is not available. Chris Johnson. LOC Chris Johnson. End of line while scanning. Okay, I missed the single quotes. Why it's not filtering the values? Chris Johnson. 1 minute. Where I'm making mistakes.
This conference will now be recorded.
Date of, see here, LOC nothing but a location. Okay, it's one of the label based data selecting method. You have to pass a label. Okay, which means label means you have to pass the name of the row or column also you can able to pass. Okay, now as of now I'm going to pass only the name of the row. What mistake I did is df dot row, and then inside this I want to pass df dot, I can provide like df dot column name. I have to provide. So column name is, what is the column name? 1 minute. Actually, the column names, df dot columns, going to the column names. Now you can filter df dot loc. LOC is another location. Okay, in that you have to pass a label based. Now df dot name equal to double equal to, you can pass Chris Johnson. Chris Johnson. Oh, it's not coming. Df dot name equal to Chris dot Johnson. Unhashable type series. I'm showing like this unhashable type series. Okay, unhashable type series. Okay, I will do slicing as of now. 2:5. Let's see. 2:5. 2:5. We are doing slicing techniques. Okay, it was not working actually. 2:5. Okay. 2:5 is also not working. df dot name equal to, name is Preslice. Okay. Unhashable type series. Okay, I will make the series data frame. Df dot, okay, df1 equal to df of name. Okay, I will print df1. Okay, df dot LOC, here I will provide df1 dot name equal to RJ Hunter, RJ Hunter. Series object has no attribute name. Okay, series object is not attribute because the convert to series data frame. Series data frame will have only the index, right? Will have only the index. Now I can pass LOC of first I'll print the df1. Yeah. Now I can do like LOC of 1, LOC of 1, max named 1 for object type series.
This conference will now be recorded.
Now what I'm going to do, I'm going to use LOC. It's a new location. Okay, in that location you can pass the column name or you can pass the row records, any other records you can filter. Okay, now in the LOC I have to use this brackets, square brackets. In the LOC nothing but location. I'm going to provide my column name. My column name is going to be name. My column name is going to be name. Okay, in the column I'm going to filter one of the row values. Okay, I need Chris Johnson. Chris Johnson. Now it's going to filter the values. Only one record is present. Around 457 rows, only one record is present called Chris Johnson. This is how you can filter using LOC. LOC stands for location in the Pandas data frame. Using this API, you can able to filter the records. It's one of the label-based data selecting method. Okay, which means we have to pass the name of the row or column we can pass to select. Okay, and then we have one more thing called ILOC. Okay, in the ILOC you can pass, it's a integer location. You can pass only the integer values. For example, if I pass 2, it's going to give second column. If I pass 3, it's going to give third column. Okay, if I pass 4, it's going to give the fourth column. Though it's a integer location, you want to pass only integer values. You should for selecting the columns. You can use ILOC, but LOC stands for select only the filter the rows. Okay, you can pass name or you can pass the any row value you can pass. That's the difference between LOC and ILOC. Okay, these two things we'll discuss it tomorrow. We have so many things in LOC and IOLOC. If you want to filter the columns, you can use IOLOC, integer location. You can pass a column index. If you want to filter the rows, you have to use LOC, and then you can provide the filter records. For example, you want to select Jordan Hayat, Jordan Hayat. You can pass this here. It's going to filter the Jordan Hayat, right? G. It's going to filter the records. If you want to filter the columns, you can use ILOC. Okay, I'm going to stop the session right now.